Hello, my name is Chris Diaz, and this is a project I wanted to talk about. This is something that was actually several years in the making. It is a custom-made MIDI controller that I built in the early 90s, like 1990 to like 1994 or so. And long story behind this project was I was working on a custom MIDI controller for a future man, Roy Wooten of Bela Fleck and the Flecktones. So there's probably another story that I'll tell in a different video, but working with him led to this custom MIDI controller which I made, which I'm going to talk a little bit about this. It is it's based on a Motorola 6809 microprocessor, which is buried under there. This is a design. Keep in mind this was done in the early 90s, so this is technology that you wouldn't probably use today, but in 1988 or so, I got a job at a company that actually used a lot of, they used the Motorola 6809 microprocessor in virtually all their products. It was a company in Cleveland called IoTech, and they made data acquisition equipment for that was based on the IEEE 488 bus or the GPIB bus or the HPIB bus, whatever you want to call it. But anyways, it was my first job out of college. It was a great experience. I learned a lot, and back then all the programming we did at that company was in assembly language. So this whole project, all the code in this whole thing was done in assembly language. There's an EEPROM right there. I'll just kind of run through real briefly what the main control board is. This one right here. So it's got a 6809 microprocessor, EEPROM. There's a RAM socket. It's empty right now. I have to reinstall the RAM. There was a device I was using there made by Dallas Semiconductor. It was a smart socket, so it was like a battery backed up RAM. So I had a bunch of those, and the battery life is about 10 years in those, so eventually they go dead. So I figured out a way to kind of hack into them to hook up an external battery. So I'm going to do another video and actually show this project, in working condition. So the RAM goes right there. Right there is a dual UART. It's a 2681 part. I think it was made by Signetics. I think Motorola makes one as well. And it was a perfect chip for this project because it had two serial ports. I was able to use one for MIDI and then one for RS-232 as like a debugging tool. All the code that I did on this project was done without an in-circuit emulator. It was kind of primitive, but the way I debugged the code was basically by using a serial port and sending out diagnostic messages as a way of debugging. So probably would not do that technique today, but that's what I did. I was working at home on this whole project, and I had limited access to tools and everything. I had an oscilloscope. I didn't have a 6809 in-circuit emulator, so basically all my debugging was done with a scope and with stereo port messages. So the other chips on this board are all TTL logic, and basically it can kind of like an overview of this whole thing. This is the front panel. It's a 16 input MIDI trigger to MIDI converter. Okay, so it's made to work with both piezo sensors as well as this other type of sensor called a force sensing resistor, or FSR, and I have some over here which I'll show in this video in a minute. But basically there were 16 inputs. These all these pots right here are like a sensitivity adjustment for every input. There's like a 4-key cursor keypad right there. There's a 16:1 alphanumeric liquid crystal display, and then there's like a contrast adjustment for the display there. So, and then on the back, if I flip this thing over, let's see, there was I stuck a bunch of stickers on here just to be funny, but I got some sticker samples from a company that made overlays, and I ended up sticking them on a lot of different random equipment I had. So now all this stuff really applies. But This was a foot switch input. I think I had this set up for a sustain pedal. And then there's a RS-232 output. I wired this up. It's a 1/8" stereo jack, so transmit and receive are wired on there with ground, and then MIDI out, and then just a 9-volt DC input. So I just want to mention this enclosure came from PAIA, which is a really cool company that I bought. I've bought a lot of stuff from them over the years. They make synthesizer modules and all kinds of really cool electronic stuff. They made a synthesizer called the Gnome synthesizer, which I bought and built, and it was a really cool device, and I had a lot of fun working with that. So they're still in business. You can check them out at PAIA.com. It's PAIA.com. So I wanted to mention them. So something else I want to talk about in here is all the inputs go to this board right here. There's a bunch of LM324 op amps, which just kind of act as like a buffer for all the inputs. And then on this board, you can't really see it, but there's a analog to digital converter. It's a Analog Devices AD7569. It's buried in there somewhere, and that's what does all the conversion of the trigger inputs to MIDI output. And I also want to mention that this board and that board were all built. It's basically perf board. It was made with wire wrapping, so that's kind of an old way of prototyping circuits. I'll probably do a video about wire wrapping, and but that's how these boards were made. I built 2 of these, and then I ended up making a custom printed circuit board. So I'll shoot another video about that. This whole project ended up becoming a printed circuit board, which I made, and then I ended up making about 12 of them, and they wound up in different kinds of instruments over the years. So that's kind of an overview of this MIDI converter. I want to talk about the sensors that were used with this device. So I'm going to talk about 4 sensing resistors now, and so this is something that I had put together. These are 4 sensing resistors, and they're a really cool device. This is one of them here. It's basically made on a plastic film, and as you can see on one side, there's like a grid of fingers that kind of intertwine, but they don't touch. So I kind of like using this analogy. They kind of look like this. Okay, so like one hand is one contact, the other hand is like another set of contacts, and then on top of them is this black carbon material. And basically, you put these on a flat surface, and as you press on them, the resistance between the 2 terminals goes down. So they're at a high resistance, and then as you put pressure on them, the resistance goes down. And I think these are used a lot in a MIDI controller made by a company called CAT, KAT. They made a bunch of really cool MIDI converters, the MIDI Kitty and the CAT drum controller, and that's what they used for that product. And I think somewhere in here I saw, yeah, this is kind of cool. When I got in touch with the company that made these, there's a company called Interlink Electronics. I think they've been sold or they've merged with other companies. But at the time when I first heard about this type of sensor, they had the person I contacted had a business card where the sensor was actually on the business card itself, which I thought was a really cool idea. You have a company with a business card, the product is actually on the business card itself. So you can see that there's a printed sensor here. So there's the fingers I was talking about right there, and then there's the carbon material. And basically, if you fold this over, it's a functional sensor, and you can put an ohm meter between these 2 leads and measure a varying resistance as you push on this. So I got in touch with this company back in 1987, I think it was, and the person I talked to there was really cool. He actually sent me like a bunch of these business cards, which I ended up using for prototypes and experimenting. And then at the time, they were selling a really nice kit with just a bunch of sensors of all different sizes. So this is something that I put together. Every sensor goes to a stereo 1/4-inch cable, and the way this is wired, I believe the ground is not connected. The tip is, I think, tied to like a plus 5 volts, and then the ring is tied to the sensor, and basically as you push on the sensor, the voltage there varies. So I'll do a video with this actually in play, with it actually functioning with the MIDI controller. But basically these would plug into the MIDI controller, and you can basically play drum beats on all these pads. And what's kind of nice about these is there's no motion at all, or there's no travel of the sensor. On a typical drum machine, you have buttons, and there's some amount of travel where they move up and down. On this device, there's no travel at all. You're basically tapping like a hard, flat surface. So I'll do a video where this is hooked up to the MIDI controller, and I'll get this all working and do a demo of it. But I just want to talk about this, kind of give a brief overview. This is something I worked on. This project was a couple years in the making, and this was back in the early 1990s. So more to come about this, and thanks for watching. Bye.